Hey guys, welcome to the notes for H8-10. We're going to be looking at factoring by grouping today and then looking at patterns for factoring sums and differences of cubes. So we'll go ahead and get started here. This first video is just going to be the one about factoring by grouping. And I added this in. This wasn't really part of our original lesson plan to teach you about factoring by grouping, but I figured why not throw it in there because it's kind of related to some of the other concepts that we've been doing. So I'll go ahead and just read the prompt along with you here. It says, as you have progressed through algebra, you have learned a variety of ways to factor polynomials. You have factored out greatest common factors, binomials as differences of squares, and trinomials as perfect square trinomials and as the product of two different binomial factors. That's all true. Okay, today you will learn how to factor by grouping when a polynomial has 4 terms or more. On the back of this paper, you will use what you have learned in Chapter 8 to discover a new pattern of factoring sums and differences of cubes. Okay, so before we go below and start doing the factoring by grouping, this is our progression for factoring polynomials. Okay, so the only one that you don't really know on here right now is the sum and differences of cubes and then the factoring by grouping. But we know that we always ask ourselves, first of all, is there a greatest common factor? Okay, and when we're doing that there, right, that usually works when there's any number of terms, right? We can always look to see, do all the terms in a polynomial have the same factor? Okay, then the next part here, differences of squares or sums and differences of cubes. Now, this is typically when there are just 2 terms, right, in our polynomial. So like, for instance, there, the one that we know right now is the difference of squares, a squared minus b squared, right? We know that factors into a plus b times the quantity of a minus b. And then it just goes into our options when there are 3 terms. When we have a perfect square trinomial, or we have a trinomial that we're going to factor into 2 binomials there. That's like your standard, guess and check method or using the box and diamond. Okay, but both of those are when we've got 3 terms. So what I'm going to show you today is how do we factor something that has 4 terms or more. And that's when we have factoring by grouping. So let's get started. The directions state here, sometimes polynomials with more than 3 terms can be factored by a method called factoring by grouping. It is not always obvious which terms to group, and sometimes several different groupings will work. So we're going to look at the first one here. The first one we've got says 5 times the quantity of x minus 4 plus 3x times the quantity of 4 minus x. So what we're looking at here, like overall, I would kind of consider this to be like a binomial, right? We've got, one plus sign in it here. So it's kind of like we have our 2 terms. Now, as we look at that, we can take that here and look for our greatest common factor. The way it's written here, I don't really see anything. In this first one, we have a 5 times the quantity of x minus 4. The second one, we have a 3 times an x times the quantity of 4 minus x. Now we know here, we've seen these before, when we have an x minus 4 and a 4 minus x, we know those are going to be opposites. So let's start out here by trying to rewrite those so that they look the same. I'm going to go ahead and just recopy the first one. I have 5 times the quantity of x minus 4. Okay, I'm even going to put here plus my 3x for right now. And then when I look at this, 4 minus x, I could take it and rewrite it as negative x plus 4 first, right? Because if I want these 2 binomials here, like the ones that are part of our factors right now, this one and this one that are within our larger polynomial, if I want those to be the same, I'm going to need to factor out a negative out of one of them. So let's do that to the one on the right here. So what we're actually going to be looking at here is I have that plus 3x times, when I factor out that negative, I'm going to factor out a negative 1. And then what's left over there will be an x minus 4. Now I can take this part here, this 3 times x times negative 1, and let's just kind of simplify that and turn that into a minus 3x there. And then we still have the x minus 4. So I'm going to take it and bring down that first part. We haven't touched it yet. Okay, but as I look at this now, okay, when we think about our factoring progression here, do we have a common factor? And in this case, we do, right? We have this x minus 4 is now a factor in each of the two parts of this expression. So let's go ahead and factor that out like it's a greatest common factor, right? I'm going to pull out that x minus 4 out here, and then we're going to look at, what's left over. Well, if I've pulled this out as a greatest common factor, it's like it's gone, right? So what's left over is this 5 minus 3x, and so we'll bring that down here. So this is like this quantity of x minus 4 was our greatest common factor, and we pulled it out. And that leaves us now with a factored form of our expression here. We have the quantity of x minus 4 times the quantity of 5 minus 3x. Okay, so that one has been factored. Now we're going to use part of what we just used in that one here in our additional examples that are coming up. So as we look at the next one here, our example number 2. Okay, example number 2, we have x to the third minus 2x squared minus 3x plus 6. So we have a total of 4 terms here. So what we're thinking about here is maybe we can factor by grouping. So what I'm going to look at doing here is I'm going to take this and group this into 2 parts. I've got these first 2, and I'm going to try to group my second 2 terms there together. So if I rewrite this now, I'm going to say x to the third minus 2x squared. I'm going to go ahead and just put parentheses around it here, just so we know that that is grouped together. Now, this negative sign is really important. That belongs to the 3x here. So we don't want to say that we're going to be subtracting anything. So I'm going to throw a plus in there. As you know, when we add a negative, it's like subtracting. And I'm going to go ahead and group those second 2 terms together. I have plus a negative 3x plus 6. So if I were to just drop my parentheses and add it all back together, I get back to my original polynomial that I'd be starting with. But what we want to look for now here is we have an x to the third minus 2x squared. So each of the terms in here have some x's here, and it looks like they each have an x squared in common. So we're going to pull out that greatest common factor. We're going to pull out that x squared from that first binomial that we've created with this parentheses. So remember, then we're taking it here, and it's like we are dividing each of these by an x squared, right? So what's left over is going to be an x minus 2. Okay, and then we have plus. Now, we see it's a positive x and a negative 2. If we look at our second set here, we have a negative 3x plus 6. And when we think about our greatest common factor there, 3 goes into both of those terms. So it looks like we could probably pull out a 3. But if I want my x term to end up being a positive, like this one is, maybe then we go ahead and we pull out a negative 3, right? I'm going to pull out a negative 3 from inside of there. So then negative 3x divided by a negative 3 is going to be just a positive x. And 6 divided by negative 3 is going to be a negative 2. So our whole goal there is we want to factor out greatest common factors so that we're left here with something that's the same between the two. And now we can look at this whole entire expression and say, hey, x minus 2 is the greatest common factor between this and this. So we'll pull that out. We have x minus 2 we're pulling out. And then what's left over is going to be the x squared, and then we have like plus the negative 3, which we can go ahead and then just write it as minus 3. And we've factored that into x minus 2 times the quantity of x squared minus 3. Now, if we were asked to solve or something, we could take that and set them equal to 0 and use the zero product property to get actual answers, but that's not what it's asking us to do today. It's just asking us to factor. Let's look at example number 3. Okay, so with example number 3, I have 3x to the third plus 8x squared minus 12x minus 32. Okay, so we have 4 terms again, right? We've got 4 terms, so maybe they will factor by grouping. Okay, let's take it here and let's see. Let's just go ahead here and group these first 2 together, and then let's group the second 2 together. So as we do that here, we say the quantity of 3x to the third plus 8x squared plus the quantity of negative 12x minus 32. I always put this plus in here. Okay, I don't try to do it with the negative. I don't try to cut too many corners there just to make sure that I don't accidentally make a mistake and factor out something I don't need to in terms of negatives. So as we look at the first one here, right, we've got, looks like they have x's in common. So we can go ahead here and pull out, looks like 2x's. So I'm going to say x squared times the quantity of 3x, and then plus 8 is left over. And then, so since I have two positive terms left down here in my expression after I factored out the x squared, obviously when I look at my next one here, right, I'm going to need to pull out a negative so that everything ends up being positive. So if you want, you can turn this plus into a minus now, or you can just leave it as plus and then just know that this, whatever you're factoring out, is going to be a negative, right? So what do we have in common between 12 and 32? Well, 2 goes into each of those, but that wouldn't be the greatest common factor. I think that 4 would be our greatest common factor. So let's pull out a negative 4, and then what's left over is going to be, well, negative 12x divided by negative 4 would be a positive 3x, and then negative 32 divided by a negative 4 would be plus 8. And you see here that we've got the same terms here. So now we'll take this and we will factor out that 3x plus 8. And what's left over is x squared plus a negative 4, or x squared minus 4. Now this one actually, though, right, isn't completely factored yet. If we look closely, we have x squared minus 4, which is a difference of squares. So we can actually take this and factor it one more time. We'll end up with 3x plus 8 times the quantity of x plus 2 times the quantity of x minus 2. That would be our final answer, or the thing that's been factored completely. All right, so we've got 3 down here for you to go ahead and try. You can pause the video now, work them out, and then check to see if you got them correct. I'm going to go ahead and work them out now, but like I said, pause it, and then you can check your answers here at the end if you want to. All right. So to try these problems here, number 1, we have x to the third minus x squared plus 2x minus 2. So let's go ahead here. Let's start out by grouping our terms. Looks like we could factor out an x squared, and we'd have an x minus 1 left over, plus, and the second one here, looks like we could take out a 2, and then we'd have an x minus 1 left over there. So our answer looks like we could end up with factoring out this x minus 1 to have x minus 1 times the quantity of x squared plus 2. And that would be our answer for number 1. For our second one, we have 8x to the 5th minus 6x squared plus 12x to the 3rd minus 9. Now this one's not totally in standard form. You'll see that we go, we have an x to the 5th, then we have an x squared, and then an x to the 3rd, and then a minus 9. Well, sometimes it doesn't really matter which order you have here, as long as you have some that seem like they'll work together. So I'll show you here on this one what I mean by that. Let's go ahead and just use it in the order it's in right now. Let's group the first 2 together. I've got 8x to the 5th minus 6x squared, right? And then I'm going to say plus, I have 12x to the 3rd minus 9 there. Okay, so in our first expression here, the first part that's grouped together, we could probably take out, a 2x squared. And what we'd have left over there would be a 4x to the 3rd minus 3. And then our second one here, we've got only x's in one of them, but then we have 12 and 9. So we know then we could take out a 3 goes into both of those. So if I take out a 3, it'd be like saying plus a 3 times 12 divided by 3 is 4. So we have 4x to the 3rd, and then negative 9 divided by 3 is going to be a negative 3. And again, you'll see here that we end up with that common factor, the 4x to the third minus 3. We'll take that out. And the part that's left over then would be 2x squared plus 3. Now those are still pretty busy, both of those binomials, but I don't see anything here that would suggest it's going to factor anymore. Okay, now, as a side note for that one here, right, I'm going to jump up here just because I'm out of space here at the bottom. Okay, I'm gonna look at that one here. What if we had like regrouped this and said, hey, this is 8x to the fifth, and instead of saying the minus 6x squared, let's say we had plus 12x to the third, and then we had minus 6x squared minus 9. Okay, so what we ended up doing here, right, like these two terms were flip-flopped. Let's see if this still works though. Okay, so if we take it here and we group those first two terms together, we have 8x to the fifth plus 12x to the third plus a negative 6x squared minus 9. And if I wanted to take out something here, okay, so now between 8 and 12, 4 goes into both of those numbers, so I can pull out a 4. And then they both have at least 3 x's, so we have 4x to the third. And then what's left over there would be, what, say 4 goes into 8 twice, and then we'd have a x squared there, and then 4 goes into 12 3 times, so we have 2x squared plus 3, and then plus, and now just like some of our ones earlier, right, these are both negative. We want to end up with positives like we have in this one. So we definitely want to factor out a negative here. Let's factor out a negative 3, it looks like. So when we factor out that negative 3, negative 6 divided by negative 3 is going to be positive 2. We still have that x squared. And then negative 9 divided by negative 3 is going to be plus 3. And you see now, right, we have different expressions here that they have in common, but they still have something in common. So we can factor out that 2x squared plus 3, and then what's left over is our 4x to the third minus 3. And when we get all the way through it there, we end up with the exact same answer here, right? Same answer here as we had down here. So sometimes, right, you can regroup them in different ways and still end up with the same answer. It's not always going to work, but it does work sometimes there. All right, let's go ahead and get through the last one here. Now you're probably anxious and ready to move on, so let's look at, we got 6 plus 2x minus 3x to the third minus x to the fourth. Okay, so what I'm going to do with this one here, first of all, I usually like to have my things in standard form, so I'm going to just rewrite it. I'm going to be careful to pair my sign with the term that it goes with. So we know my x to the fourth term is negative, and my x to the third term, right, is negative. And then we had plus 2x plus 6. So now when I group them here, okay, let's look and see what they have in common. Right, this one, the one on the right here is all positives, so I'm going to go ahead here when I'm factoring out of the first one here, I'm going to pull out a negative. And it looks like we're just going to pull out a negative x to the third. So that would leave us with a positive x plus 3. Then we have plus. And over here, we're just going to take out a 2. And that would give us an x plus 3 as well. And then we'll take it here, last step, factor out that x plus 3. We have the quantity of x plus 3 times the quantity of negative x to the third plus 2. And you could rewrite that as 2 minus x to the third, or you could factor the negative out and put it all the way out in the very front. Doesn't really matter that much there. Where it's at right now, it's just fine. And that would be our answer for the last one. So this is factoring by grouping. This is lesson H8-10. I'll go ahead and go into the second video for the sums and differences of cubes, but hopefully this makes sense. Let me know if you have any questions. Thanks for watching.